Hello, on this problem what we do is we are going to find the equation of the tangent line to a curve. Now, in general, to find the equation of the tangent line to a curve, what we need to do is to find the derivative. So what we're going to do is, and why do we do that? We find the derivative so that we can find the slope of the tangent line. So the slope of the tangent line is equal to the derivative. I'll just write out a sentence. The slope of the tangent line is equal to the derivative evaluated at the point where we have the tangent line. I call it the point of tangency. The slope of the tangent line equals dy dx at the point 3/2, 3/2. So we find dy dx, and then we plug in the numbers 3/2, 3/2. What makes this problem different is that our equation given here is defining y implicitly as a function of x. And at our point of tangency, if we just look at a little point around there, y would be a function of x. So there's some more we can talk about that, but let's move on to actually finding dy dx. Okay, so what I do is I write down this equation here where y is mixed in with x's, and I don't solve for y. That would lead to a very difficult equation, and it would just not really be worth our time to do that. I mean, really, in many cases you can't even do it, but you definitely don't want to do that here. I don't know how to. I think there's some way though. But okay. So here we have d dx, and we apply derivative d dx to both sides. That's derivative to both sides of this equation. That's the steps of implicit differentiation. So we apply that to both sides there. Okay, so let's see how this works out. Now, when I'm going to look at each piece here, I take the derivative of y cubed. Actually, I could even expand this. It just takes so long, but I might do that. The derivative of y cubed plus the derivative of x cubed minus 3, the derivative of xy equals the derivative of 0, which is 0. All right, now, when I come over here to this, come back over here on the left, when I take the derivative of y cubed, I think of this as using the chain rule, which I mean, I don't think about it. That is what I'm doing. So the derivative of anything cubed is 3, whatever that anything is, to the second power. But what that is y. And the chain rule says we go back, then we go inside and take the derivative of what's inside, and that's y prime. Y prime being dy dx. Then we come over here to the next piece here. So the first one we just did was derivative of y cubed. Now we take the derivative of x cubed, and that's 3x squared. You could multiply by x prime. X prime is 1, so there's not really a point of doing that, but you could just write down x prime. X prime is 1. Now for this next piece here, we use the product rule. All right, because we have a product, two factors, x and y, we're multiplying together. So taking the derivative, we use the product rule. We have x prime y plus xy prime. So the product rule says take the derivative of the first factor, leave the second factor alone, plus leave the first factor alone, derivative of the second factor, and then we write down the right-hand side is 0. Now, the Openstax book, which you can go look at because it's free, you look it up and you can see a worked out solution for this. What they do is they solve for y prime, which definitely we can do. We can solve for y prime. But what I'm going to do is I'm happy with y prime being mixed in with the x and y's, and I'm going to go ahead and put in x equals 3/2 and y equals 3/2 because I think it might be easier to simplify if I have numbers that I put in there. So I'm going to put in x equals 3/2, y equals 3/2, and I'm going to let m being slope equal to y prime at those numbers. soon as I put those numbers in for x and y, it's not really y prime anymore. It's y prime, evaluate those numbers. By the way, when I have x prime over here, x prime is equal to 1. So let's go ahead and do this. It's true, I'm going to lead to some fractions, which will, you know, I don't know, it might make it a little more of a challenge, but I think we're up for it, aren't we? So, okay, I did that, you know, a little bit quickly, but everywhere I see y, wherever I see y, I put in 3/2. Wherever I see x, I put in 3/2. Wherever I see y prime, I put m. So this becomes 3 times 9/4 m plus 3 times 9/4 minus 3/3 plus, well, actually I should distribute that. Okay, so minus 3 times 3/2, which makes 9/2, minus 3 times 3/2 makes another minus 9/2 m equals 0. We can multiply by 4 to clear the fraction. That's a sort of a beginning algebra trick. You look at the least common denominator, which is 4, multiply through, makes it supposedly a little easier. So when I multiply by 4, 4 divided by 4 is 0. Multiply by 4, 4 divided by 0. Multiply by 4, 4 divided by 2 makes 2 times 9, which is 18. Multiply by 4, that makes 2 times 9 is 18. So multiplying through by 4 gives 3 times 9 is 27m, plus 3 times 9 is 27, plus, or minus 4 divided by 2 is 2 times 9 is 18. Minus 4 divided by 2 is 2 times 9 is 18. Getting there. So 27m minus 18m makes 9m. And 27 minus 18 makes 9. And then almost there, 9m. 9m equals negative 9, and m equals negative 1. So we found the slope, and now we're almost there. So that's our, except I wrote it down wrong. Slope is negative 1. M equals negative 1, that's our slope. We already have the point. So the point is x1 equals 3/2 and y1 equals 3/2. We are now able to use the point slope formula. Y minus y1 equals m x minus x1. So we get y minus 3/2 equals negative 1, x minus 3/2. And all of a sudden I decided to make everything more spaced out, which looks better, but now I'm running out of space a little bit. I'm going to move it over, shrink it or something. Got to get everything in here. Maybe too small, but still, okay. All right, so going over here, this makes y minus 3/2 equals negative x plus 3/2. So y equals negative x plus 3/2 plus 3/2. So 3/2 plus 3/2 is 6/2 divided by 2 makes 3. So y equals negative x plus 3, and that's the equation of the tangent line. And that was sort of, if we believe this picture is true, it was sitting right in front of us the whole time. You know, here we have this tangent line right here, and we see that the y-intercept is 3, and we can, you know, calculate the slope by looking at the picture, and that's negative 1. But we wanted to do this without just looking at the picture, at the graph, you know, that was given. Okay, so I guess that does that, and again, this is Openstax Calculus Volume 1, and so that's an open source book, free book, and you can just do stuff, make videos, and study that, and you go to openstax.org to look at that. Okay, thank you, that's good. That's all, goodbye.